Hello and welcome once again to Andy and Ian Talk Networking. I am Andy.
And I'm Ian.
Hello and welcome. Yeah, so today, Ian, I think we've talked a little bit in the past about packet capture, and we've talked about packet brokers and taps and spans and all the kind of networky stuff to get our observability data in. I think what we should do now, though, is start digging a little bit into the analytics and the packets and kind of what's going on, actually on the wire. So
Okay,
yeah,
sounds exciting.
I
Let's do it.
I think what we should do then is move a little bit up the stack then and talk about kind of how the data is actually then used within the environment. So one of the key things I think is metadata versus the packets, because we all know that packets are great and they're wonderful and we can dig down and we can understand exactly what's going on if we like ones and zeros with our Wireshark traces. But actually, at the end of the day, that's not particularly useful for a lot of people, certainly at the high level when they're trying to understand what's going on. So I keep hearing metadata is the key and we're going to do everything at a metadata level, and why do I need to see packets? So let's dig into that first and start off and kind of what are the differences between the two, and kind of how does it all work and how does it all come together.
Wow, you really like to pick these fun, easy subjects, Andy. It's great.
And we're going to crack it
So
out in 10 minutes.
we're going to try and give it our best shot. So the simple summary is that if I have packet data, I'm going to be doing analytics, right? That's really the key
Yep.
phrase is I'm doing analytics on that packet data, and that will generate metadata, which is kind of taking this vast amount of packet data that I've been capturing and is going to effectively make it smaller, right? It's going to be looking at TCP analytics. It's going to be looking at
Mm-hmm.
conversations. It's going to be looking at all, different VLANs. There's lots of different slices of metadata, but effectively you're taking all of that packet data, you're running it through some kind of an engine to be able to, you call that analytics usually, and that will then generate this metadata that's usually doesn't have any of that PII type, that personal identifiable
Yep.
information in there. You're taking a lot of
Getting
that
rid of that.
away.
Yep.
Yeah, and it also then reduces the volume of all of that data, which is then going to make it much easier for a management tool to be able to consume that data when you want to be able to give you that high level. I always oversimplify by saying a kind of a red, amber, green kind of
Sure.
model, just a kind of a quick snapshot. Hey, what's going on in my network today? Oh, something unusual.
Yep.
Drill down, and you can very quickly see exactly what's going on because you can go back all the way to that packet data, or certainly using cPacket, that you can get all the way back to the packet data
Yep.
if you really do want to have that eating Wireshark for breakfast. Was that what you just said a few minutes ago, Andy? Something like that.
Yeah. Yeah, and to me, I think one of the key things though is that you've got the metadata is much more consumable. So, don't get me wrong, packet data, Wireshark data is absolutely great. We all love digging into PCAPs, but a lot of the times, if your tools are trying to analyze, tens or hundreds of gigabytes worth of data, it just slows everything down. So
Yeah.
by taking that packet data, analyzing it within an edge-based tool that brings that up into a metadata, strips all the payloads out, and then starts to really understand kind of maybe round trip times, latencies, TCP into gap delays, all those kind of wonderful things. We can bring that up into a much more consumable format in the form of the metadata that we can then analyze very quickly and without passing hundreds of gigabytes worth of data between packet captures and analytics tools.
Yeah, I think you highlighted actually something really important there that I hadn't, don't think I was very clear about. I mean, the spirit is that you're going to have many of these devices. Once again, the person that's likely listening to this probably works for a large enterprise,
Yep.
uh, government, large distributed kind of network, and lots of branches, all of that kind of style. So you do want to be able to aggregate, and that was the word that I think I hadn't said,
Mm-hmm.
aggregate all of these edge devices together, take all of that metadata, squirt it up into a management or visualization or graphing tool, or, or,
Yes.
or
Yeah.
whatever you might want to have, something that you're spending a lot of time in,
Mm-hmm.
so that you're able to then see that everything brought together rather than going box by box by box around the network.
Yeah.
Go and actually look at that central location because you've taken, as you say, all of that hundreds of gigabytes of packet data, you still need that because you want to be able to go back and look. But
Yeah,
just for that quick snapshot, hey, what's really going on? As you said, TCP delays, latency, things like that. If I'm looking at either lots of distributed locations or just lots of capture locations through a very complex networking
yeah,
path, I can bring together all of that data so I can see the connections going all the way from your client, to my client or whatever it is, and
yeah.
I'm able to very quickly understand what's going on by aggregating all of that data together
Yes.
into the metadata kind of
Yeah. And
simplification.
and obviously the other big thing is that 99% of the time the network doesn't change. So having looking at hundreds and hundreds of gigabytes worth of data when nothing has changed is pointless. What you need to do is to bring that metadata up into a tool that can just show you a straight line. Oh, look, now I've got a blip. Now I need to worry about that bit. Rather than just saying, well, okay, it's 9 o'clock in the morning. I'm now going to read PCAP files for the next 8 hours before I go home. You've actually got this ability to kind of streamline it and actually just look, as you said, just for the problems that you're interested in because they've been highlighted, etc. So to me, I think it's really important that the metadata is obviously it's smaller, it's easier to consume, but also it's easily digestible by multiple tools and multiple different applications in the network.
Yeah, absolutely right, Andy.
Yeah.
Absolutely right. No one wants to get that phone call. Actually, I don't know if people still get phone calls, but anyway, the point is you get a phone call on your big red telephone on your desk. No one wants to get that. So when that comes in, it's definitely a problem. You need to very quickly be able to zoom in through that metadata because you're really seeing exactly what's
Yeah.
going on, and you're able to then zoom right down into that packet data
Yeah.
to be able to check
Yeah,
out
it's that
really
it's
what's
that
happening.
recall time. It's the ability to search much faster. Yeah, it's the ability to actually search at a higher level and then
Yeah,
drill down exactly into kind of what you're looking for. And that really again comes, I said, back to the visualization thing. So the
yes,
metadata is really giving you the ability to visualize and search much quicker. But also because it's so much smaller, the amount of data, you can feed that into the tools. The tools don't have to deal with huge amounts of contents of packets being moved around. And also you can get one of the things I like about it is you can get without actually having the payload, as you mentioned about the PIP and this personal information that's embedded in that payload. Without the payload, you can still get a lot of what's going on within the
yes.
network. And and in a lot of applications, that payload is encrypted anyway. Even just web traffic, that you've got the SSL connection that just encrypts everything. So really, the information that you care about is held in the header, which could be easily extracted up into metadata.
Yep, absolutely right, Andy. Absolutely right.
Okay, so anything else we want to cover on metadata versus packets? Obviously, packets rule, but metadata I think is the
Well,
key here.
I think the funny thing is, and I know we it's not tongue in cheek, right? It is very serious, right? The idea that packets do rule, they do have all of that data there. But I think it's really important for folks listening to be able to really think about what level of data they want to see in their tool. If
Yeah,
their tool is that they're consuming the data from is remote, you don't want to fill up your entire WAN by shoveling packet data around.
yeah,
Metadata will give you a quick snapshot based on every packet, though. Very important.
yeah.
Don't let's get stuck in that sampling route that
No,
we
no, no.
spoke about on a previous video. But the spirit is you're going to have all of that data. It's not going to be that PII concerning data, and you're going to be able to bring everything together so that you will very quickly understand where an issue is, what's happening, and most importantly, how you're going to be able to fix it quickly so that that
Yeah.
phone on your desk, assuming you still have one, stops ringing.
Okay, absolutely great. Thank you very much, Ian. Appreciate your time
Thank,
as always. So
thank,
with that, we'll leave it there. Again, once again, please don't forget to like and subscribe if you enjoy our content. It's very useful for us and the analytics within YouTube to recommend to other more interested parties. So again, please don't forget to like and subscribe. And yes, once again, thank you very much for your time. Goodbye, and see you next time.
bye for now.